Greetings to you all. This is Stephen Magezi and Patrick Anaku. We are doing a presentation about MLOps, how to deploy and how we are going to deploy our model so that it is accessible over the internet. After training our model, we identified the best performing model as EfficientNet. And below are the tools we used when in our ML ops process. Below are the tools we used, and as they are illustrated below, we started. Tool number one is PyTorch. This was used to define and load the model into the ML ops deployment area using the library Torch Vision. We used Fast API. This is the web framework that we use to create the API endpoint. We as well used UVCon. This is an asynchronous server gateway interface, ASGI, that is used to run the Fast API, or that is used to call the Fast API. We used Pillow. Pillow is where we deployed to perform image loading and pre-processing. Somewhere when we are running the model over the web, you will see a space where we attach an image before it is classified. This is where Pillow comes in. We also used GitHub, which we used for for code management and version control of our code. I request my colleague Patrick to pick it up from here. Thank you.
Okay, yes, Stephen, thank you for that. So I'll pick up from procedure we used to implement this MLOps. Like my colleague has mentioned, we used PyTorch to first of all do the training, and it also runs the model in production. So the first step was for us to load the pre-trained weights from the trained model. After we trained the model, of course, we saved it and we downloaded it. We are running this test on a local environment where we have the tools my colleague mentioned set up. So, and step 2 involved us deploying the Fast API, which involved installing it. Then we also wrote some Python scripts, 2 scripts that allows us to interact with the model. So I'll demonstrate this. One of them being main.py, which is the main script that runs the model. Then there is another script called model.py where we have the model definitions for our trained model. Then we have an API endpoint called predict, which runs the model in order to make predictions on any image uploaded by a user. Yeah, let me take you through the MLOps pipeline we came up with. So this is just a visualization of the entire process, right from data collection or data processing all through to the final model. We'll be majorly focusing on the sub image on the right, which starts from code integration. That is where we focused our MLOps on after training the model and downloading it. So the first part there involves GitHub, where we have code versioning. That's both on the code and on the model itself. This is done through the help of GitHub. Then there is Docker component somewhere where if we want to put the model in full production, we containerize it using Docker. Then of course we have our continuous integration and continuous development pipeline, which pushes various versions of the code into production. So let me go through the code itself. Let me look at some demonstrations on how the predictions happen. So here is our main API, the one I mentioned earlier, the script called main.py. It's where we define the API endpoint. We only have one endpoint here called predict, and it has this function called predict, which basically handles file upload. That's one of the things it does. Then it also calls the function that loads the module with the pre-trained weights and runs it. Then the model makes prediction based on the submitted image. Then the other script is basically where we define the model. Of course, we have to run the structure, the training structure of the application, things like the channel attention model, spatial attention. This is just basically using the forward pass when the model is trying to make inference on certain images that have been submitted. Yes, that's the major parts of the code. This is similar structure to what we use in the training itself, only that it's basically for inference purposes. So basically here what we want to do is see, let me just stop this. I'll run it, then I'll show you from the beginning. So this is already set up on localhost. If we run this, it's going to, I just need to stop this fully. Okay. I run the model, it runs on localhost port 800. And if I click, I think there's already a running instance. If I click on this, it should open on the browser on localhost. And this is the API endpoint, the one we defined. So if we want to make prediction, we can simply supply an image. For instance, there's a sample which we're going to try and analyze and see which class it belongs to. So we supply this image, which is going to run through the model, and the model is going to make predictions and tell us which image it is. If we execute this, it runs and we get a prediction on in which class that particular image belongs in. So it's in archaic image class. Basically, that's just an illustration of what's happening in the backend. So this is the API front end. For the rest of the MLOPS part, all this code we've done here is version and pushed to GitHub. If we look at the GitHub repository, we've set up workflows that pulls the code from the code base localhost, pushes it to GitHub. Then from GitHub, we've done some GitHub actions. If you remember the topology I was illustrating earlier, there are GitHub actions that does the Docker containerization and the final pushing of the code to production. At that point, we can have different versions of that code. So for example, this is just a pipeline. Like this is one of the GitHub actions